Hey, this is Mr. Janes. In this video, we'll be discussing how to show if figures are congruent in two different ways. Now, in the past, you may know that congruence means same size, same shape. And while that's true, in this video, we'll be moving on to two more rigorous definitions. The first method we've seen before. The second method will be new to this video. Again, same size, same shape works, but we're going to move on to something that's a little more rigorous. The first one is using transformations. To prove that two figures are congruent, you need to explain a sequence of rigid transformations, remember those are translations, reflections, or rotations, that maps one figure onto the other. So if we look at this grid right here, our first example, we've got quadrilateral A, B, C, D, and quadrilateral E, F, G, H. And if I wanted to prove to you that those two quadrilaterals were congruent, what I could do was specify a sequence of rigid transformations, so some sort of translation, reflection, or rotation, that would map maybe this blue figure onto this red figure, and that's what I'd like you to do right now. Off to the right, it says, in order to map A, B, C, D to E, F, G, H first, and then there's some blanks. Go ahead, pause the video, and fill in those blanks explaining how you get from A, B, C, D to E, F, G, H to prove they're congruent. Pause the video now and fill in those blanks. The answers will be up on the screen in 3, 2, make sure you pause the video and try this. So before I go over them, I just want to note that remember, these are my answers, this is the way I transformed it, but there could be hundreds of other ways to do it, and in fact there are infinite ways to complete this proof right here. But I wrote, in order to map ABCD to EFGH, first rotate ABCD 90 degrees clockwise about 0, 0. That's what I've done here, you can see that in green. Then translate down 4 and to the right 2. So if I do that here, that's 1, 2, 3, 4, and to the right 2. You can see I've now mapped ABCD to EFGH using rigid transformations. I continue to write, since the figures can be transformed onto each other using rigid transformations, now I can say that ABCD is congruent to EFGH. Now it's important that I wrote those letters in that order because I need the letters to correspond to each other. What that means is that A and E are the first letters of each of these quadrilaterals, and that's because A and E mapped onto each other, right? After I transformed A, it landed on E. B and F were the second letter, and that's because B transformed onto F. C and G were the third letter, that's because C transformed onto G, and D and H are the last letter, again, because D transformed on to H. You can see that right there. So writing these so that they line up like that, so they match up or correspond, is important. What I'd like you to do now is go ahead and try the second example. Explain to me how I know that ABC is congruent to triangle DEF. Now you can write it however you'd like, but I suggest you use some of the same language I used above. For example, use the same words such as in order to map or since the figures can be transformed, and definitely write a congruent statement at the end. So go ahead, see if you can write your own few sentences here to explain to me why ABC in blue is congruent to DEF in red. Pause the video now and try and write that explanation out. The answers will be up in 3, 2, 1. So I have, in order to map triangle ABC to triangle DEF, first reflect triangle ABC over the y-axis. I've done that here in green. Then translate down 6. 1, 2, 3, 4, 5, 6. There it is. Since the figures can be transformed onto each other using rigid transformations, triangle ABC is congruent to triangle DEF. Again, you can see that those letters correspond to each other. A and D map onto each other, B and E transformed onto each other, and C and F transformed onto each other, just like that. So, this was the first method to show that two figures are congruent using transformations, but there's also a second method. Method 2, congruent sides and angles. Look back at the transformations for method 1. Do congruent figures have the same side lengths? Do congruent figures have the same angle measures? Well, let's check. If we look back at the last example, let's look at some side lengths. From A to B, we've got 2 right there, and from E to D, it's also 2. So it looks like they have the same side lengths. What about the angles? B and E correspond. B is a right angle, E is a right angle, so it looks like also the angles are also congruent. Well, that's because rigid transformations, such as translations, reflections, or rotations, preserve the side length and the angle measures of the figures they transform. That's really crucial here, so make sure you write that down. As a result, we can say that if two figures are congruent, then their corresponding parts, the sides and the angles, must be congruent. Thus, the second way to prove that two figures are congruent is to show that all the corresponding sides and angles are congruent. Now that may sound a little confusing, but let me show you an example right here. We've got these two triangles here, ABC and PQR. Now, if I want to prove to you that these are congruent, I could put these on a grid and use some sort of transformations. Or what I could do is show to you that all of the corresponding angles and all of the corresponding sides are congruent. Let's look at the angles first. Here on angle A, we've got these two red marks. And angle P over here, we've also got two red marks. Those mean that the angles are congruent. They have the same angle measure, whatever it could be. You know, whether it's 30 degrees or 40 degrees, we don't know, but they must be the same because of those markings. They're also on B and Q, so those must also be congruent. And C and R have 3 each, so those two must be congruent. So we can write down angle A is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R. What about the sides? A and B have this one little red tick mark on them, but so do P and Q. That means that they are congruent, the side lengths. They have the same length. Maybe it's 3 inches, maybe it's 10 feet, we don't know, but we do know that they are congruent because of that marking. BC and QR both have 2, so they are congruent. AC and PR both have 3, so they're congruent. So we can go ahead and write down that AB is congruent to PQ, BC is congruent to QR, AC is congruent to side PR. Now we've written down all of the corresponding angles, all of the corresponding sides, so since all the corresponding angles and sides are congruent, we can say that the whole thing is congruent. Triangle ABC is congruent to triangle PQR. So again, instead of using a transformation, we can go angle by angle, side by side, and if they all are congruent to each other, then the whole entire figure is congruent. What I'd like you to do is try the same thing for this next figure. Write a short paragraph, just like I've done up here, that names all 6 corresponding parts, 3 angles, 3 sides, and then explains that the figures themselves are congruent, just like I've done up here. Pause the video now. The answers will be up in 3, 2, make sure you've tried it. Here are the answers. From the figure, we know that angle E is congruent to angle S, angle F is congruent to angle T, angle D is congruent to angle R. Now, watch out here. A lot of people say that F is congruent to R because they're kind of close to each other and they're both pointing up, but that's not true. F's got 3 red markings, R has 2. Those are congruent, but F and T both have 3 red markings, so those are congruent. As for the sides, we have EF is congruent to ST, FD is congruent to TR, and DE is congruent to RT. Wait a second, those are segments, those should have the line above them. Since all corresponding angles and sides are congruent, I can go ahead and say that the whole thing, triangle EFD, is congruent to the other whole thing, triangle STR. Now, make sure that when you're writing this congruent statement out, you make sure that the letters correspond to each other. E and S correspond, so they're both the first letter. F and T correspond, they're both the second letter. And D and R correspond, they're both the last letter. Now, it doesn't matter what order you put them in, like you could have had FDE is congruent to TRS, as long as those letters correspond to each other on either side of that congruent symbol. Let's flip to the backside now and do a couple of problems involving method 2, corresponding sides and angles. First up, is each pair of figures congruent? If so, write the congruent statement. If not, explain why not. So I'll help you through number 1, and then you can try 2 and 3. So remember, to show 2 figures are congruent using corresponding sides and angles, we have to verify that every corresponding angle and every corresponding side is congruent. So let's get started. Angle D is 78 degrees and I is 78 degrees. Looks like C and H are both 143. B and G are both 86, and E and J are both 53. So all the angles that correspond are congruent. What about the sides? Well, between D and C I've got these 2 marks, and between I and H I've got those 2 marks. Between C and B I've got that 1 tick mark, so that's congruent to HG with 1 mark. Again, As I'm doing this, notice them going around the polygon in the same order to make sure that those corresponding sides and angles are not only congruent, but also corresponding. They're in the same order, right? They're not kind of mismatched. And it looks like they are in this one. So I can go ahead and say that yes, the figures are congruent because all of the corresponding sides and angles are congruent. Now I can write the congruent statement, such as DCBE is congruent to IHGJ. Now, the order doesn't matter for either of them as long as the corresponding angles and sides match up. So for example, D is the first letter here and I is the first letter here, and those angles correspond. So I could write it something like BEDC or GJIH. Those are congruent as long as, again, I make sure that my letters correspond. So like B and G, here's B, here's G, they're both 86 degrees, they correspond. Or lots of other possibilities. What I'd like you to do now is pause the video and try and answer this question, are they congruent, for numbers 2 and 3. Remember, if they're congruent, write the congruent statement. If they're not, explain why you know they're not congruent. Pause the video now. The answers will be coming up in 3, 2, 1. Make sure you pause the video. Even if you're a little confused, just the act of trying this out and thinking and struggling with it will help you. Alright, here are the answers. Looking at number 2, no, the figures are not congruent. Although the corresponding angles are congruent, the sides are not. So like we've got this 23-degree angle here and this 23-degree angle there. And all the angles line up nicely, but in fact, there are no markings or indication on any of the sides. So we don't know if they're congruent or not. They could be similar, which means one could be a dilation of the other, bigger or smaller, but they're not going to be congruent, not that same size, same shape. What about 3? Well, 3 is a little interesting, right? Because almost everything is marked except for side TK. All of the corresponding sides and angles are congruent except for side TK, right? This one in the middle, right? Is that congruent? Well, I mean, TK will always be congruent to itself. It's kind of that shared side between this triangle here and this triangle here. So I guess we could say that TK is congruent to TK. That's called the reflexive property. And we'll learn a bit more about that later on. But for now, if you're a little confused, that's okay. In the end, we can say that triangle RTK is congruent to UTK. Again, those letters correspond to each other. Lastly, we can add a little bit of algebra to congruence. If two figures are congruent, then the corresponding parts, the sides and angles, are also congruent. We knew that. But now we can use this information to solve numeric and algebraic problems. So, for example, in this figure right here, MNP is congruent to QRS. You know what, let me mark up this diagram first before we go any further with the corresponding sides and angles, and I suggest you do the same thing. So, for example, I know M and Q correspond, so M and Q are going to be congruent. Let me just put those marks there. And I know N and R correspond, so, okay, N, I'll put 2 on, and R. You know, let me fast forward this process, but you do this yourself. Make sure you know what sides correspond to what other sides and what angles correspond to what other angles. Go ahead and do that yourself. There, I've marked all of those. Hopefully you have too. And now that'll help me answer some questions. Like, what does MN equal? Well, MN isn't labeled on this triangle, so I don't really know. But I do know that MN corresponds to QR. I've got this yellow one mark that I put on there, and they're both the first 2 letters of these congruent statements. And QR is 8.3. Since they're congruent, MN must also be 8.3. What about angle Q? Well, angle Q here, it's purple. I don't know what it is, but I do know that it's congruent to angle M. So it's got to be 72 degrees. There it is. All right, pause the video here and try number 2. The answers will be up in 3, 2, 1. As you can see, I've marked my diagram up nicely, and now I found, I didn't know what JM was, JM, but I did know it corresponded to KL, so it's got to be 16.1. And measure of angle JLK. Well, JLK, that's this angle right here in purple. Now, I don't know what that is, but I do know that it corresponds over to this angle here, which is 50 degrees. So JLK must also be 50 degrees. Lastly, at the bottom, we've got a couple algebra problems, which look pretty bad, but actually aren't so hard. Number 3 states that the triangle LKJ is congruent to triangle BDC. Find the value of S. Well, the variable s is here in this expression. Looks like the measure of angle L is 3s minus 20. Well, that doesn't really do anything for me unless I actually know what the measure of angle L is as an actual number in degrees. Well, wait a second, I do. I know that angle L and angle B correspond to each other, so they must be congruent. And angle B is 55 degrees, so angle L is also 55 degrees. So 3s minus 20 must also equal 55 degrees. So I can write a little equation here. 3s minus 20 equals 55. Then, to figure what s is, I can solve that equation. So 3s minus 20 equals 55. I can add 20 to both sides and get 3s equals 75. Then I can divide 3 from both sides to get my final answer. S equals 25. S equals 25. Great, that's my answer. Just to double check that that does work as an answer, I can substitute 25 back in for s and see 3 times 25 is 75 minus 20 is 55. So yeah, if s is 25, then L is 55, and that makes sense because L is supposed to be congruent to B by this statement up here. Perfect. What I'd like you to do is try number 4. A, B, C, D is congruent to E, F, G, H. Find the value of x and y. So there's a little hint. If you're looking for how to find what y is, think about what it's got to be congruent to. Either 135, 28 degrees, or this right angle, and write yourself an equation. Same thing for x. Really, this is kind of 2 problems in 1. Pause the video now and try to set up equations for x and y and then solve for them. The answers will be up in 3, 2, 1. Alright, here's for x. We know that x is part of this expression, 10x plus 65, and we know that f, being the second letter up here, must correspond to b, the second letter up here. So that's 135 degrees. So I set up this equation, 10x plus 65 equals 135. Subtract 65 from both sides to obtain 10x equals 70. Divide both sides by 10 to get x equals 70. On the other hand, y, right here, is the measure of 4y minus 4 is the measure of angle E, and from up here I know that E corresponds with A, this 28 degree angle. So I was able to write the equation 4y minus 4 equals 28. I added 4 to both sides to get 4y equals 32, divided by 4 to get s equals 8. I'm sorry, that is y equals 8. There you go. So x equals 70 and y equals 8. I hope you've learned the 2 ways to show that 2 figures are congruent. Once with transformations, which we've done for a little bit, and this new one using sides and angles. It's not too bad, but there's a lot involved with it. So if you need to, make sure you go back, rewind this video, pause when you need, and I'll see you in class.